Hello, thank you for coming. This is the biggest crowd I've ever talked in front of. This is exciting. I'm going to talk about Trigger, which is an open source toolkit for performing network automation. It's specialized for talking with network hardware, and I'll go over all the crazy things that it can do. I'm going to give some operational examples and then also code examples. You're warned now that it's going to be a little bit advanced if you're not a programmer, but I've tried to keep it pretty easy to follow. So here we go. So about me, sorry, I skipped ahead. I've been working in networking in system engineering for over 18 years. I've been at AOL for the past 12 years. I've worked on the network security team and the network architecture and automation team at AOL. I'm a hardcore Python coder. I've been using Python now for about 7 years. Excuse me. Before that, I coded in Perl for about 12 years. I will never use Perl again. I avoid it at all costs. It was funny because I've used Perl longer than I've used Python, but I always hated Perl. No offense to any Perl users out there. So I said I work for AOL, and some of you probably things popped to mind, and I have a good idea of what you're thinking, asking questions like these. So it's yes, yes, no. But there's a surprising amount of brands that you probably use all the time and never really think that it's AOL. And we still have a very large global network. All the tricks, DNS, GSLB, you name it, it goes on and on and on. We have some Engadget, for example, when we have whenever there's an iPhone launch event or an iPad, any of these crazy Apple things, we get record-breaking traffic, and it's a really exciting time to see if we can keep the show running. This hinges heavily on the network hardware. So it takes a big network to run all this stuff. Our network has shrank over the years because of all the trials and tribulations, but we still have over 6,000 network nodes. That's including routers, firewall switches, and load balancers, among other things like wireless controllers. You know how the whole ecosystem of network hardware goes. We're working on rolling out new virtualized network equipment, but that is still because AOL's been it's a mature company, has a very large network. Still a lot of die-hard hardware people, and it's a hard turning point to get to that virtualized world for network hardware or network nodes or devices. So having said that, we have a big network, lots of hardware, very diverse ecosystem of hardware. What is Trigger? Why do we build Trigger? And fundamentally, Trigger is a network automation toolkit. And what exactly does that mean? What the heck is network automation? A lot of you are probably used to system automation, using Linux boxes or whatnot. So Trigger is kind of like Chef or Fabric or Puppet, but it's tailor-made for network devices. And you ask yourself, okay, what is that? So router switches, firewalls, load balancers, I mentioned those already. We can technically support systems too, but that's not what Trigger is designed to do. So why Trigger? Why did we design a new thing? Why didn't we use something that was already there? Well, first of all, we had a large suite of tools that were built mostly in Perl, and everything was run synchronously, serially. So you had a list of 10 pieces of hardware you want to change things on. You had to wait for each one to finish in turn. So we decided in 2006 we were investigating some kind of asynchronous tool suites out there, and we found Twisted, which was written in Python. And we all generally agreed that we hate Perl, so we're like, okay, let's give Python a shot. And here we are 7 years later. And one of the biggest things that Twisted was able to give us, because it's a very well-written suite of tools, is that we needed speed and reliability. We needed to be able to know when we needed to be able to run lots of commands on lots of hardware in parallel. And we were in a world where engineers were spending the maintenance windows every morning for hours with multiple terminals open, just running the same commands on multiple devices just to try and get the work done before the maintenance window was over. It was ridiculous. You didn't get any sleep. You didn't get any work done. So that was another thing, too. If there was an error case, you had to go and edit the config file to cut out devices you've already loaded on. It was a real pain in the butt. So error handling was important so that we could just keep going and catch all the errors and then report them at the end and just eventually work through the work queue. And we needed scalability. We needed something that wasn't tied to a single system. We wanted to be able to scale this to any number of systems and kind of do this whole model of systems that know about the network and the association to the data that is supposed to be attached to those systems. And our tools can handle these thousands of devices running commands in parallel with relative ease and hardly any resource use on the systems. It's really nice. We wanted extensibility. How many of you have used Rancid on your network hardware? Show of hands. Okay. So less than I thought, but that's okay. Extensibility. Rancid, for example, is a toolkit that allows you to run commands on devices. It's in spirit what Trigger does as well, to some degree, but Rancid has this whole thing where it backs up configs. And it's mostly written in Perl and expect, and a lot of the device interaction code is all expect. And it's not a very flexible language, and it's also something that's not easily extensible. So Python, by nature, any program you write is a module, and therefore you write that code, it's very easy to reuse it. And we have done that in spades in the Triggers library code. We wanted integration. Say if you have an entire Cisco-based network. Cisco has these management tools that are like, oh, just click the GUI or click the push button. And when you have a large network that scales beyond a certain size, or if you have a vendor diversity, say if you have Cisco or Juniper or Foundry, their integrated GUI management solution, it immediately becomes a burden versus an asset. And it's really hard to automate GUI clicks. We designed Trigger in a time before this new era of DevOps when network vendors didn't have APIs. You think about some of the vendors out there right now, like Arista. They're very popular in the switching world now, and they have a full-blown API that you can leverage to talk to the hardware, and so you get machine-readable input or output back, and it eases the development process. So fundamentally, what we really needed, all this boils down to remote execution. We wanted to be able to asynchronously execute tasks on network hardware. And so we support SSH, telnet, and JunoScript. JunoScript being Juniper's XML API. It's an RPC-based API. And yes, we support telnet because we still have hardware on the network that doesn't support SSH. And cry a tear for us. And so in order to get this powerful toolkit that knows how to talk to network hardware, we established a network device metadata tool or library. And this is kind of at the core to how you work with devices in Trigger. You have all these different attributes like the vendor, the make, the model, the location, the ACLs that are applied to the device, whether the device supports SSH, and I'll get to some of these examples a little later. So it makes it so you can pretty much do similar things to like database queries, but without a database. What we've done in production is we've taken a dump from our asset tracking database, or our CMDB, and taken all the fields for all the relevant network hardware and used that to populate a metadata file, like either JSON or XML, and we also support CSV. And I'll show some examples of that later too. So one of those pieces of metadata is actually more complicated. It's bounce windows. Having a global network with thousands of devices, we can't make the changes at the same time everywhere because of the peaks and valleys of the usage across the world. That probably makes sense. So we have there's a configurable module that you can put in a place where either you tell Trigger where or you put it where it expects to find it by default, and it will populate those bounce windows for you. So you do it based on time, like the hours that you want, and we have 3 risk levels, which is green, yellow, or red. And so you can define your windows of like, okay, in green you can make these certain types of changes, yellow these, red no changes. So it's another nice little piece of functionality you can leverage to add intelligence to your tools. And one of the things that we really wanted to get rid of was clear text passwords stored in people's home directories. Trigger has a way to cache your network credentials, say your TACAX username and password, store them in your home directory, and encrypt them and decrypt them when it needs them. This is a way that you can have users run tools without having to always put in their username and password. Excuse me. Rancid does that, and Rancid still to this day stores the passwords in clear text in a file, like a dot. I think it's .clognrc or something. So our equivalent is .tacxrc, and I'll cover some examples of this as well. And the fundamental problem that we still to this day is that every single vendor implements their connectivity in a different way. If you think about what that actually means, look at Linux for a minute. You can pretty much assume at this day and age that every Linux system you get on is going to have a bash shell. Every Linux system is going to have the ls command, the cp command, the cat command, et cetera, et cetera, et cetera. GNU has taken us a long way. But that does not exist in the network world. And in fact, through years of talking with vendors and urging them to adopt a standard, there's an IATF standard or an RFC standard called netconf. But on the whole, depending on what vendor you're talking to, all bets are off on how you're going to interact. A large majority of them emulate Cisco's very well-known iOS configuration format, but they also have their own tweaks and flavors. And then one of the hardest parts is actually going back to how you connect to the device in the first place. Some vendors only support allowing you to get a shell on the device. Some vendors support SSH exec, which is what you would expect if you were to type SSH hostname command. And some vendors require you to do some kind of weird PTY, which is get a virtual terminal and shell together. Some won't give you a shell. It's confusing and it's a pain in the butt. And this is why we have Trigger. So I'm just going to show you a list of supported platforms. I'm going to go over, I'm just going to mention them at a high level so you don't have to read the entire slide. We support A10, Arista, Aruba, Brocade, therefore Foundry because Brocade acquired Foundry, Citrix, NetScaler load balancers, Cisco, all the routers and switches running iOS. We don't support any of the new stuff like Nexus or iOS XR just yet. Dell and Juniper, both the NetScreen firewalls running ScreenOS, which is old school, and then all routers and switches running Junos. And that's, these days, I think that's the bulk of most people's networks. I'm just making a wild guess there. One more thing. On the Juniper hardware, by default, it uses script, but you are able to also tell it to use CLI instead. It's a nice little way to be flexible. JunoScript is preferred because it's so much more robust because you're getting machine-readable data back, whereas when you do CLI commands, obviously you're getting human-readable data back, unless you specify otherwise. So here's where it's going to get technical, if it wasn't already. I'm going to go over some examples of some of the high-level features of Trigger. I'm going to give a few examples of some of the command line tools that come with Trigger that are leveraging the underlying functionality, and then I'll show you code examples that emulate or that illustrate what exactly those commands are doing behind the scenes. And then some of the other stuff is just straight up code examples. All of these are going to be done using the Python interactive interpreter. So that's your forewarning there. So if you're used to Python, you may have used pip before. Pip makes it very easy to install packages that are hosted on the Python package index. It's like Python's version of CPAN. And so to install Trigger, all you need to do is run pip install Trigger, and it will automatically install all the dependencies. Trigger is also very easy to set up. We've done a lot of work to streamline the configuration, and as of the latest release that we just launched last week or 2 weeks ago, we added support for CSV files, which makes it, all you have to do is provide a host name and device vendor tuple, and one per line, and it will allow you to get up and running. And so it's an easy way. If you already have a list of your devices by host name, you can just jump right in. So I'm going to just show you a brief example of this. So if we assume you installed Trigger, and I'm going, even though you already installed Trigger, I'm going to clone the repo just so that we have access to some of the example configuration files. and those are found in the conf directory of the source distribution. There is a configuration setting called net devices source that allows you to specify where trigger is going to find the device metadata. And so in this case, I referred it to the CSV file. And you see that CSV file there has two devices, one Cisco and one Juniper. And these are going to be used throughout the examples here. So this net devices source setting can also be provided in Trigger's global settings file. And I'll illustrate those too in a minute. So we just quickly told Trigger where to find the net devices metadata file, which is conf.netdevices.csv. And then we just hop right into the Python interpreter and import the net devices module, or the net devices class from Trigger's net devices package. Instantiate it, and you can see that what it did is it populated itself with net device objects. And so the net devices object is a dictionary-like object, but it also has a lot of special methods that allow you to search for or interact with the network devices. It's like the container from which you're going to draw your network device metadata and extract net device objects from. Going back to this really quickly, so down to the bottom you see the net device test1abc.net.aol.com. The net device object itself is what contains all the attributes and special methods that allow you to interact with the devices, such as getting an interactive shell or executing commands asynchronously, or just analyzing the metadata and collecting devices by, say, their vendor or their location, or whether or not they're in the bounce window, those kinds of things. So Trigger is relatively easy to configure. All the configuration settings are very well documented. All you have to do is drop settings.py into etc Trigger, or you may customize that location by way of the environment variable. So at the top here, I am copying the sample trigger settings trigger_settings.py over to etc Trigger settings.py, and this is just a snippet here. When I cat the file, just a snippet of a couple of the settings there. I left the comments for those of you who like to read fast. Basically, net devices source is there. You can specify the default location you want it to read from, or say if you're debugging, you can overload that value with an environment variable. And so by default, Trigger these net device loaders, and this is kind of a chain of responsibility pattern, or plugins, if you will, that allow you to, if you want, customize the types of, or the source of your metadata by providing a module path that Trigger will try to import and then instantiate. By default, Trigger comes with support for metadata from CSV, JSON, XML, SQLite, and Rancid. The Rancid support and the CVS support is very basic right now. It just reads in a handful of fields, and I'll illustrate that in a second too. So you see at the bottom there, I gave an example of a custom loader. We just call it MySQL loader. We don't actually have one built in a Trigger yet. And you see here what I've done is, instead of providing a single string, which is a module path, you provide a two-tuple of the first item being the module path, or the path to the class, and then the second or any subsequent arguments in that list will be passed to the constructor once it's loaded. So this DB user dictionary, this dictionary here, will be passed to the MySQL loader class. So here's an example of, once we've put the settings file in etc Trigger settings, or etc Trigger settings.py. So if we hop into the Python interpreter again and import from trigger.conf import settings, this is the global settings, it tries to read it. You can reference that environment variable there, and you see that it read the network device metadata from the file location specified there, etc Trigger netdevices.json. Now see there, on the second example, if I specify the environment variable ahead of time, launch the Python interpreter again, and do the same thing, you can see that it loaded it from the location I specified. And the next two are just to give you an example of a couple of the settings. These are little internal mechanics that you can tweak. For example, modify the default timeout for or executing commands on hardware, or modify whether or not you're going to allow interactive shells via SSH on a certain manufacturer or the certain device types for that manufacturer. So in this case, we've disabled interactive SSH logins on Dell switches, and that's actually a default in Trigger because Dell's SSH support is mega broken, and they have no plans of fixing it. So I talked a minute ago about the network device metadata, and this keeps coming out because a lot of this interaction all hinges on the metadata itself. And so this is done by way of the net devices class, and I just repeated the example I showed before where I'm importing the net devices class from the net devices package and then instantiated it. And this pattern is repeated all across Trigger's code. You see this nd equals net devices. So it's kind of the vernacular. When you're referencing nd, it's that you're going to try and look up some metadata. And so in this second example, we're creating a dev object, or we're pulling a dev object out of the net devices. And even though it is a dictionary-like object, so you could reference that as if it were the host name as if it were a dictionary key. You could also use the find method. And the find method allows you to do a partial host name match so that you don't, if you're doing it, debugging by hand especially, you don't have to type the whole host name every single time. It's a nice little handy feature. There's a lot of little under-the-cover methods like that that really ease in collecting and collating devices. So here's just a little example of two of those methods and then two attribute calls. So the node name is the host name. The vendor is actually a special object that allows you to do comparisons between vendors, either by a string or by the object itself. So it allows you a little more flexibility. This is considered to be the canonical name of the vendor because we thought about that. What we've done, we have names that we call the vendor when we put assets into our database. But we can't assume that everybody's going to use that same syntax or that same name. So, but we can probably assume that if somebody's putting a Cisco piece of hardware in their system, it's probably going to have the word Cisco in it, or the name Cisco, or possibly start with Cisco. So that was kind of the idea there with the canonical name of a vendor. And then those two method calls, isRouter and hasSSH, those are just identity tests or functionality tests. And we try to auto-detect SSH so that it's always tried first, and in the event that SSH fails, we'll fall back to telnet. You can optionally disable telnet support in the configurations if you want to, and I do recommend that. Make a conscious decision to use telnet. And then this match method down here, it allows you to specify key value pairs. So I could do vendor equals Cisco, node name equals foo, and all of those become search criteria to return a list of net device objects. And then you can imagine if you've narrowed down a list of devices that you want, you can iterate that and do your work, write your code. So here's an example. This is the help output of one of the commands that comes with Trigger. It's called netdev, and it's just a simple command line interface for the net devices metadata. And I didn't do this for any of the other commands to show examples, but I wanted to illustrate some of the other attributes that you can search on that are part of a network device. Or a net device object. So you see here we have location, the host name, the device type, the owning team, the on-call name of the team, the owning organization, the vendor, manufacturer, budget code, budget name, make, model. It goes on. I haven't even put all of them in here just because these are the most commonly used ones. So here's an example. If we do the -L command, which actually lists the output for a single device, this test1 ABC device here was one that we populated earlier from that CSV file. And you can see here that a lot of the fields are not populated, and that's because all we'd specified by default was the host name and the vendor. And you see there that it's got the host name as test1 ABC and the vendor is Juniper. And then you see there's only two other fields that are populated, which is type of router and admin status of production. The type is also populated by, if you don't specify it, it's populated by a configuration setting that it's the fallback type. And by default, the fallback type is router. But you can also specify fallback types for each vendor if you like. And then the admin status is whether or not the device is up or down, or whether or not you should consider connecting to it with tools. By default, Trigger will only work with devices that are marked as up or in production. But you can override that if you like to make it work with all devices no matter what. But it's a nice way to filter out things that you don't want your production tools to run against. For example, systems that are in the lab or systems that are in development or testing or staging, et cetera. So here's an example of the same thing, but what I've done instead is populated it with a bunch of phony data, but relatively realistic data, just to give you an idea of how you might populate these in reality. The location, the project, the serial number, asset tags, all these types of fields, and these turn out to be very, very useful. So we talked about error handling at the get-go, and this is something that we really do leverage the power of the Twisted framework for. Twisted is a callback-based framework, so you can either fire callbacks or you can fire errbacks. If you've used Node.js, it's the exact same type of programming style. It can be very confusing. So a lot of this code, throughout a lot of the trigger code, as much as possible, I've tried to hide the implementation details of Twisted. There's two reasons for that. One, Twisted can be very confusing to program in, especially if you're not used to it. So we don't want to scare away beginners or newcomers to the project. But the second reason is because we want to someday be able to swap out Twisted if we like. For example, using Geovent and Paramiko instead of Twisted's SSH client and event loop. So here's an example based on, these are some exceptions that are built into Trigger. And so you see here at the top, that's a timeout error. So that occurs when you've tried to connect to a device, but your connection timed out, like it timed out trying to log in. Or you have a command timeout, which you have a certain window. Every time a command is executed and output comes back, the timer is reset. And I think it defaults to 30 seconds. So you have 30 seconds between each command that's executed in the stack. And if any one of them times out, this error is thrown by default. And the last one there, this is in the event that if a login fails. So there's a lot more here. These are just some simple examples. So to give you an idea of that, there's a lot of state going on within Trigger's underlying code, and it gives you a lot of really power to just keep on trucking if you catch any of these errors. So bounce windows are a way that we can isolate what should be done at a certain time. You can pull a list of devices that are only eligible at a certain time zone or a certain site location or a certain risk level like green, yellow, or red. So the time zone support is built in, and we by default manage everything in UTC time. Trigger expects to find your custom bounce window mappings within SE trigger bounce.py. That location is also configurable in the settings, surprise, and or by way of an environment variable. And so the easiest interface to the bounce window API is just to reference the bounce attribute on any network device object. They all have them. And this by way of the bounce.py module that you may or may not have defined, it's going to return a default object if it doesn't find one. But for example, I don't know what time zone this is, probably East Coast. You see that the green bounce window for the East Coast is 3 a.m. to 5 a.m. And we've filled it with yellow from 0 to 2, 6 to 11. This is one of the recent changes we made too. The old API was very cryptic and relied on heavy developer knowledge. I feel like this new model is very human readable. You can see here that's a bounce window, and you have the green, yellow, red, and the hours there. If you've ever used a cron tab, those hour patterns make sense. You're also able to specify the default color for a bounce window. So if you really want to populate the red, say I want it red from 12 to 23 and default green, you don't have to populate the other two. You don't have to populate the green, the yellow attributes. So then a bounce window object also knows when the next green or yellow or red time zone is based on this information, or sorry, green, yellow, or red maintenance window is based on this information. So how is this decision made? So the trigger change management bounce module itself expects to load a bounce function from the, this might be confusing, from the bounce.py file that you've put into SE trigger settings, or sorry, SE trigger. And based on that module that you can customize the behavior of the bounce function. So that's where you can do kind of rule-based code to say if it's a device that's in, you know, Mountain View or in the West Coast, put it in this bounce window, or if the device has SSH, put it in this bounce window. All Cisco's, never let them load anything, that kind of thing. And so next up is, well, you're doing all these connecting to devices, you're doing all this executing commands. So Trigger stores your credentials for you. And the current method is a little bit insecure, but it's as secure as we try to make it. One of the assumptions is that you are going to be connecting to and managing your network hardware from a system that you trust highly. So the people that have access to that system, you also trust highly. Now, of course, that does not make security people all that happy, but it's a good enough solution if you've got strict controls to access, to get to that host to begin with. So that's kind of the model we got here. So these credentials are stored in your home directory in a TACXRC file, .TACXRC, and the information is encrypted using a passphrase that is specified within the configuration file. And so that's the limitation there. The security risk is that the passphrase is readable, is world readable by everyone on the system, because everyone has to be able to read the settings file. So the way we work around that is to make sure that only the owner of the .TACXRC file has access to read that file. So that does mitigate a lot of the risk. If you have people who are enterprising and have root access, they can do whatever they want, but when has that ever not been the case? So here's just an example of what happens when there's this tool called Go, and Go is your interface into doing using Trigger to get interactive shells on devices. So instead of using SSH or telnet manually, you just use Go, and it figures it out for you. Go also has some really cool extra features that I'll show in a minute. But here's just an example of what the encrypted output from the .TACXRC file looks like, and you can see at least it's obfuscated. It's not the greatest. We do have a functionality to use GPG encryption that we had got working at one point, but there's a lot of overhead and it needs more work because it's relying on the command line GPG utilities to be installed in the system, and it also expects that you're going to be using GPG agent. So if you think about what you have to do, you have to tell every user that they have to put GPG agent into their .bashrc, and then they have to generate their own GPG passphrase, and that can actually be very intensive on certain systems. So it's half-baked and it's not very well documented, but if you're brave, we do have a document inside of the Trigger documentation that tells you how to do it. The front end towards TACXRC functionality is the TACXRC class, and when you instantiate this class, it will read your .TACXRC from your home directory. And then it stores passwords in it by realm. So the default realm is also a config bit that you can specify in the global settings. By default, it's AOL because we're egotistical. But you see here, going back to the previous example, when you first create your username and password and cache them, it stores them there at the bottom. You see AOL uname and AOL PWD. So when you start adding new realms, you can add special realms for special devices. For example, let's say you have some firewall hardware that isn't using TACX, and so it doesn't have global or centralized authentication. You have a one-off administrative username and password for that device. You can make Trigger store that in the .TACXRC. So it's a way that you can actually have an entire credential store. It's not just going to store the single username and password. Okay. So here's just a couple examples of, first of all, referencing the AOL realm and getting back a credentials object, which is a name tuple. So you have username, password, and realm. And then here's a function here, get device password. You can specify the realm as an argument. And if it finds that realm within the .TACXRC, it will retrieve that data and send it back to you. If that realm is not found, it will prompt you to create and cache credentials for that realm, and then ultimately return that credentials object back to you. So So this takes us to, I gave you an example of the Go script, and the Go is probably one of the most commonly used tools in the toolkit. And it only supports SSH and telnet. It might not be obvious, but it may be because JunoScript, for example, is not a human protocol. So it's pointless for you to be able to connect interactively and use JunoScript. So here's just two examples. You can provide a full host name, or you can do a partial host name, and it will search, and if it's the only match, it'll automatically connect you to that device. Or you can do a partial host name, like a non-specific match, and it will return you all of the candidates that it thought were there. So that allows you to save a lot of keystrokes. As long as you don't have too many devices named with the same pattern, you usually get around pretty easily. And you'll see there at the bottom, or maybe at the top, it says use Control X to exit, and we did that. We blocked Control C, or we disabled Control C or remapped it to Control X within the interactive shell, because there are some devices out there that use Control C as a special character, for example, Cisco. Like if you're doing a ping or a trace route from a Cisco device, the only way to end that ping, if you've specified an indefinite one, is to do some things like Control C, Shift 6, some weird crap. So that's why we have that. Go also allows you to specify a .gorc file in your home directory, and this is where you can define commands that you would like to execute upon connecting to a device. Because you can't really specify those things, you don't have a bash RC on network hardware. This is kind of like your system-side bash RC for your network devices. So it's called .gorc, and here you can see here I've specified two definitions for Cisco. I'm going to run term length 0 and show clock when I log into any Cisco device. Or Juniper, I'm going to run show system users. So I'll just have two examples here of, at the top, connecting to a Cisco device, and you can see that as soon as I connect, it runs those commands. And the same thing with the Juniper device at the bottom there. I log in, and it executes show system users as the first thing. Now you're thinking, oh, that's dangerous. What if someone puts a reboot the router in their GoRC? Well, we thought about that, and there are all the commands are whitelisted, so only certain commands are allowed to be executed, such as show and a couple others. So that, yeah, maybe someone's clever can circumvent it, but it prevents you from shooting yourself in the foot, at least at a basic level. Sorry, that was my elbow. Generally, the model within Trigger is trust your administrators, trust your users. Trigger does not do command authorization at all. We're relying on TACACS to do that, or whatever you're using to do your authentication. Except in the case of the init commands, because automatically executing commands on any system or hardware can be very dangerous, given whatever access level you have on that system. So here's the two examples at this previous slide using the Go script. And then in this following slide, it's the same exact thing, but using the API, or using code. So every device has a connect method that's what the Go script is actually doing, that connects you and gives you an interactive shell. And then if you pass the init commands argument and provided a list of commands that you'd like to execute, that is the equivalent of what is being read in from your .gorc file. So when your .gorc file is read, it populates init commands and sends that along to the connect method. So remote execution is the other thing we use Trigger a lot for, running commands when you don't have an interactive shell and capturing that output, and optionally doing some kind of state machine, like a send expect thing that you're probably used to in a lot of cases. Where you say, okay, I'm going to run this command, I expect this output, do this with the output, run the next command, go on and on like that. So given we have this alien and we have this remote execution and this send expect type of behavior, we can highly customize the tools. Okay, we're almost done here. I'm moving right along. So to execute a command at the very basic level, you use the execute method, and then you pass it a list of commands as the first argument. There are a lot more arguments, but I'm not going to get into that right now. But you see what happens there when you run execute. It returns a twisted deferred object, and this is a callback base. It's this kind of thing where the behavior is dictated by other callbacks. You can't do anything with that by itself, and that requires internal knowledge of twisted, and I was not going to get into that in this talk. So we have this library called Commando, and it's part of the commands library. And Commando is a very elegant base class that allows you to subclass it, or you can even just use it by its base to execute commands. And the default behavior is run this command, store the output. Doesn't do anything else. So you see here on this second line, the second example, I've created a Commando object, and I populate it with a list of devices to run commands on, and then a list of commands to run on those devices. In this case, it's only one device, and it's only the command show clock. Very basic example. We call the run method, and then once it's done, you get a results object, which is a dictionary with all of the output that you expected. And if there are errors, there's an errors attribute that has a dictionary populated with the error messages. So here's another example. This is the command line tool gNng. How DevOps is that, the ng on there? It's actually get nets, and we're running, the example, I forgot to change the host name. So, so you see here what it does is it gives you a map of the interfaces, the IP addresses, the ACLs that are in and out on those interfaces. It's very useful it's kind of like doing ifconfig on a network device, but without having to log in yourself. And this is done by way of another default class. It's a subclass of Commando. It's highly customized it knows about a lot of the major vendors to be able to connect to that device, get a list of the interface stuff, parse it, and then produce a dictionary of a normalized dictionary of all the attributes you wanted. And so in this case, I created the net ACL info object, I ran it, and then at the end, I referenced the interface FE121 from that dictionary results, and you can see there that table at the top there that's displayed by the getnets tool, the first line, actually just came from this simple dictionary. So debugging is really hard when you're doing event loops, especially asynchronous or thread-based stuff. I'm sure some of you probably know that. You can't just do print statements because print is not thread safe. So Twisted has a logger that is thread safe and does not block, that allows you to do really advanced debugging, and it's very easy to use. So I'm just going to illustrate that a little basically, just to give you an example of how easy it is to turn on the login. So the log object comes from Twisted Python, and then I wanted to print my logs to standard out. So what I've done here is I've called the logger, told it to log to standard out, and that second argument there is set std out equals false. If you don't tell it to do that, it will redirect all of your standard output, including your keystrokes, and that can be really confusing during debugging. So you really only want the logs themselves but usually you only want the logs themselves to go to standard out. And so then I just call the connect method on a device, and you can see there that a lot of this underlying debug logging shows up on your terminal. And this is immensely useful. And especially if you're coding against the trigger libraries, you can just import the Twisted Python log thing at the beginning and do this, and just make calls to the log.message method on the log object, and create all your own logs. So you can intersperse. It makes it really easy to jump in. Twisted log method or function or log object is compatible with Python's default login module, so you can create observers or subscribers, those kinds of things. So now we get into the final nitty-gritty here, and then I'm going to leave some time for questions if you guys have any. These are the most complicated examples. This requires writing actual class-based code. So I talked about Commando a minute ago. Excuse me again. And so here I'm creating a Commando subclass that all it's going to do is run the command show clock, and it's only going to support Cisco platform, the Cisco platform. By overloading the vendors there, if the vendor for a device that you've tossed to the show clock object is not supported, it'll throw an exception and won't let you continue. So it's like, sorry, that's a Juniper device. I'm not going to run show clock on that. Pull it out from the list and try again. So here I've got two devices that I just completely made up. Create the show clock object, pass it that list of devices, run it, print the results. And what do we get? This is at the top there. That's some of the debug logging. Just shows you that it's sending those commands there. And one of the things I wanted to illustrate there is you see that I've got these two devices in this list, foo1 ABC and foo2 XYZ. So lists are ordered by index, but what you see here is that we've added these to the stack, and what ends up happening is that foo2-XYG, I babbled and lost my train of thought. What? Yeah, the order there is reversed. So because Twisted is asynchronous and these tasks are run in a deferred state, you have no guarantee of what order they're going to be run in. The commands on the devices, we do control the order, but the order in which the devices themselves are connected to and interacted with, we can't control. And then you can see that there, too, based on the timestamps. Even though we actually connected to foo2 XYZ first, we actually got by microseconds? 2 microseconds slower. I don't know why. But that does illustrate that both devices were communicated with almost like at the exact same time. And we have scaled the apps to do like 50, 75, 100, 200 connections at once. It just goes. It's awesome. So here's a more complicated example. This is another show clock. This is a more detailed show clock class, mostly the same. But what I've done here is I've defined this from Cisco method. And there are from and to methods for every vendor. It'll automatically map the vendor to a from or to method. So this makes it really easy to write these subclasses. You're like, okay, so I want to dictate the behavior of what happens when output comes back from a Cisco device. So I'm going to define a from Cisco method. If I wanted to dictate how a command was sent to a device, I would say define the to Cisco method. But in this case, I'm just using the default to Cisco method, which just sends the commands along. But here, what I've wanted to do is when the clock timestamp comes back, I want to parse it and store it as a datetime object. So that's what this little functionality here is doing. So I'm parsing. The from Cisco method calls the store datetime method with the results that came back from the device. The store datetime method calls the parse datetime method, and then parse datetime just tries to return a datetime object. Otherwise, it falls back to the string, the timestamp that came back. This is a very simple example of the kind of power you can have to parse and interact with the hardware. This is something that we haven't open sourced yet. We really want to. It's kind of like the next generation that I think this is a very advanced application written around the trigger libraries. It's called the Commando API. And what this is doing is building on the Commando class functionality to create command adapters and workflows, but providing a language agnostic interface to be able to communicate and write applications around triggers functionality. So what we've done to use this is we've leveraged Celery and Django to create a RESTful API to allow us to interact with, like, create tasks and asynchronously. And if those of you who don't know anything about Celery, it's an AMQP library for Python. And it allows you to take advantage of all the power of the AMQP protocol, like the task states and task chaining and task dependencies, scheduling, retries. It's very, very powerful protocol. And of course, REST these days is very easy to use. It's very easy to write applications around. We're using all the HTTP verbs the way they should be. So here's just a very simple example. You pass it an API key, the list of devices, and the username associated with that API key. And what happens is, on the back end, the API key is associated with your network credentials. And we've tried to think of a lot of security around that, and it's not perfect yet. And what happens after you, so I've got this task here that's show clock, and that show clock task is bound to that show clock class that I illustrated a minute ago. And so what happens after you submit this task is it gives you back a task ID. And then after some amount of time, when the task has completed, or you think it may have completed, you can pull the API to get the result, and you can see that it returns you a JSON blob of the results that came back from the devices you specified. If it were an error, it would tell you the error, and it would give you the traceback and the exception, and it's all very, very cool, and I'm very excited about it, and can't wait to open source it. one of the things, one of the things why Commando was conceived is that we have a large network, lots of old tools, 5 different ways to do the same damn thing, and it makes it really hard to bring the infrastructure into the modern day when you have to make, if I say I want to add IPv6 support, okay, we have to update 5 different tools in 5 different places to do the same damn thing. And so we're trying to forgive the sins of the past of managing network hardware by easing the way we can build apps that talk to the network and not assume that everyone has to be a Python programmer. So there's a couple extras here that I wanted to talk about briefly, and here we go. So Trigger was founded in security, network security, and so we have a really powerful ACL parser that supports Cisco, Juniper, Foundry, Brocade, Arista, and NetScreen firewall policies, and you can transcode them between each other, which is really cool. I didn't want to showcase this feature because we're trying to pull it out of Trigger because we feel like Trigger's outgrown that functionality, and this feels more like a bolt-on now. So we're going to move the ACL parser into its own project and then change it so that it's an optional feature of Trigger that you can configure and install on the side. So here's just a simple example. You have this ACL here, .123. It's a Cisco access list. Use this ACL-conf tool that comes with Trigger. Pass it the -J option that says convert it to Juniper, and here you see it spits out a Juniper firewall policy to standard out. You could also do the same thing in reverse. You could take in a Juniper ACL and spit out a Cisco ACL. Very, very cool. And this allows us also, since we're reading in firewall policy into an in-memory object, we can do all kinds of awesome tests, like is this access here, and automate the whole firewall processing thing. And we have done that. It's just a story for another time. Yeah, thank you. So last thing, really quickly, and I'm going to just breeze on by, is we have custom notifications. And this is just another little thing that's pluggable so that you can say, okay, if I had this internal monitoring system and I catch an error, send an alert to the monitoring system. By default, it uses email. Here's some bits here. You specify notification handlers. And then what you do is you can import the send notification function from the notifications package and send a notification. And that's all it is. That's all it does. And it returns true or false whether or not the notification succeeded. So what's the future of Trigger? Open source. This project is always going to be open source. Open source. We put a lot of work in getting the document and the code ready to go because it is a mature project. But we open sourced it last April, and it's completely designed. Twitter, email, with Wiki. We use the issue tracker and GitHub. We're trying to stay public and get as much interaction and feedback as possible because I think that this project is really only just getting going now that it's open source. So find us on Freenode. And that's it. Thank you.
Check. Okay, so we're going to do some quick Q&A in a second. Lunch is at 12:30 in the Plaza Ballroom lower lobby level. I'll get in directions if you need it. If not, go down and around to Plaza Ballroom. Okay, does anybody have any questions for Jathan? Raise your hand. Here we go.
So reading through the docs, I have to ask, do you really still use RCS?
Yes.
No religious questions.
I would love to switch to Git, but RCS is simple. It's always guaranteed to be on a system or very easy to get, and it's basic. That's all really we need is something that just tracks revisions very simply. But the lock-in is a nice feature of RCS. For example, if you have an engineer that's editing a configuration file, another engineer goes to edit the configuration file, RCS will be like, nope, you got to wait. And that sometimes is a lifesaver. Yes?
When can we expect Commando?
When can you expect Commando?
To be open source.
Soon, any day now. It's been in prototype, and I just got it to a stable state on like the last few weeks. It does not yet support IP tables. It's a long story. I can talk to you after if you want.
You're converting between a lot of different formats and command sets. Do you have any intermediate format files or anything?
For what specifically?
Anything.
Commands?
Commands or the output from the switches or routers?
Kind of. That's kind of what the Commando library is meant to do. the show clock is meant to be an example of that. And the NetACL info one is a way more detailed example of that, where that effectively with the NetACL info class is a layer for show interfaces. So if you think about that, we have the potential to build that type of functionality for anything. And if you think about salts, grains, if you've used salt, it's exactly that, kind of like that. But we have not built a lot of the default functionality in yet. Yes?
Hey, so in the example where you were calling run to the commando object, and then right after that it said print results, isn't that an issue? Like if the results don't come back fast enough, that there won't be any at that point, or do you have to like
the results
wait for
will not come back until the entire process has completed. So not until all devices have returned results, you will not be able to access that attribute. Or if you did somehow, it would not have results in it yet. Yes.
So how hard is it to add support for other vendors' hardware, like F5 was absent?
That is a great question, and we have done a lot of work to really improve that process. But when we first built Trigger, all we supported was Cisco and Juniper. Now you see we've quadrupled that number of vendors. We were trying to move it to more of a driver-based model, but we're not there yet. So it is a little tricky, but some of the support we've added lately, especially for SSH channels, SSH exec versus SSH PTY, there's a good chance that F5 might just work out of the box. We just haven't tested it. So I encourage you to do that and get back to us. I'd love to hear your feedback.
So I think we're pretty good for questions. So hey, Jason, thank you very much for taking the time to talk to us about this, and also working on this awesome project and keeping it open.
Thank you.